All right, what we're going to do in this video is look at elasticity of demand, a very important topic in economics and business, and actually uses a little bit of calculus, so who knew? So the definition of elasticity is referred to as the responsiveness, or what we call the sensitivity of demand. So elasticity of demand, and it's expressed as a percent change. And what we're looking at is how much does it change, or not really fluctuate, but change for every 1% price change. So essentially, elasticity of demand, which I have down here labeled as a letter E, is the percent change in quantity over a percent change in price. So it's measured as a ratio of ratios, I guess you could call it. Okay, so just a little bit of background about demand functions first. There's two basic kinds of demand that we're going to examine. We have the linear demand here on the left, which that's just kind of our easier case. Linear functions, as we know, are easier to handle, easier to solve equations and whatnot. So we do assume that a lot of demand is linear because honestly, if you close in on the interval of potential prices, it usually looks at least a bit linear. But if you have a commodity that is more sensitive to price changes, you might see a demand curve like the one on the right here. So as you notice, it starts out sinking slowly as price increases, and all of a sudden it just starts dropping really fast. So that just means that demand dissipates very quickly. So those are the two kinds of demand that we're going to talk about. So in the elasticity formula, though, I want to make it clear that remember, or note, I should say, that this quantity right here is negative. And because we don't like dealing with negative numbers a whole lot, we usually put a negative in front of the elasticity, or at least I should say we do for our purposes here, because we want to make elasticity a positive number. The denominator is always going to be positive because we're assuming an increase in price, which means delta P is going to be positive, and delta Q is negative. So that's kind of our idea with elasticity, but I want to rework that expression to make the calculus happen. So we know that elasticity is negative delta Q over Q divided by delta P over P. Now, whenever we have a division of two fractions, we always multiply by the reciprocal of the denominator. So we have negative delta Q over Q times P over delta P. And now what I'm going to do is I'm going to rearrange it so that the deltas are together and the non-deltas are together, I guess you could say. So we have negative P over Q times delta Q over delta P. Now, that's what would happen if we actually increased P by a set amount and then the quantity would decrease by some set amount. But if we're talking about instantaneous, those deltas become derivatives, and what we have is negative P over Q times dQ dP, which is the derivative of the demand with respect to the price. Okay, so that's our formula that we're going to use for elasticity. But we're not quite done there yet. We still have to classify what is happening here. So thinking about the ratio. If the elasticity is greater than 1, then we know that the demand is sensitive to a change in price. So let's explore that for a moment. Let's say E is 2, just off to the side here. Okay? So if the elasticity is 2, that means that the percent change in quantity is double that of the percent change in price, which means I better not change my price any more than that, or else my demand is really going to tank. So an elasticity of greater than 1 is essentially going to tell me I shouldn't be increasing my price anymore because it's really starting to tank. So if E is less than 1, this is that demand is not sensitive to change in price. Now, we do have words for this. If E is greater than 1, we call the demand elastic. And if E is less than 1, we call it inelastic. You know, think about a rubber band. If it's elastic, it's very sensitive to change. If it's inelastic, it's not moving, right? Now, if E is equal to 1, demand and price change the same way. Okay, so if an elasticity of 1, that means if the demand goes down by 2%, the price is going up by 2%. There's kind of an equilibrium happening there. Okay, so we call E equals 1 unit elasticity. Okay, so those are 3 classifications of elasticity. Now there's even a more exciting thing happening here, and that is the relationship to revenue. There is a relationship between elasticity and revenue. So here's what it is. So let's say R is revenue. And remember, revenue is price times quantity. But remember that quantity is a function of price. So that means this has to be treated as a function. I'm going to differentiate both sides with respect to P. Which means on the left, I'm just going to have dr dp. On the right, though, I'm differentiating a product. The derivative of P is just 1. The derivative of Q is what we would call dq dp, just like we call the derivative of y dy dx. And now all of a sudden we have a product rule. So it's 1 times Q plus P times dq dp. And I'm going to simplify that just a little bit just to be able to do something with it later. Now, we know that when revenue is maximized, the derivative is equal to 0. Okay, so what I'm going to do, I'm actually going to manipulate this equation to show something here. So I'm going to move the Q to the other side here. And do you notice that on the left-hand side, that almost looks like the elasticity formula, but without the Q? Well, if I divide both sides by Q, or rather negative Q, I get E equals 1. So when E equals 1, we have unit elasticity, as we know, which also means that we have max revenue. So then what happens at the other places? Well, it turns out that if E is less than 1, revenue is increasing. And if E is greater than 1, revenue is decreasing. So if if elasticity is less than 1, that says you're not affecting your demand that much. If you increase the price, keep increasing the price until your demand catches up with your price. If your elasticity is greater than 1, stop increasing the price because you're losing so much demand that it's actually taking away from your revenue. So there's the relationship between revenue and elasticity. What we'll do in the next video is we'll look at a couple specific examples of how this all works and kind of bust out the cobwebs with the algebra. And so we'll save that for then. I hope you learned from this, and thank you for watching.